All right. Very good morning, very good evening, everyone. Let's get started. Right. We can quickly recap on what we covered yesterday. This is a second demo session, continuation for our yesterday's demo session, and then followed by next weekend onwards, we're going to start with the regular classes. Let's quickly go over what all we covered yesterday, and then we'll cover today's whatever the planned topics for this demo session. Right. We started with a discussion about this course, and we started with introduction about me and overall experience and what all my primary skills and all those things, and followed by course curriculum, what all the course content, what all will be included in that, and followed by the course duration, fee structures, and the course timings, and followed by how we're gonna access the Google Drive, all the course materials, course content, and the lab exercise, all the softwares, all the recordings, everything will be in the Google Drive. And along with the course materials and the all the softwares and all the course recordings, you'll be getting the previous batch recordings so that you can well in advance you can prepare and you can attend the class. Right. And then also we discussed about once we start or commence or begin the class next week onwards, we'll be having a different Zoom link and the meeting ID or the Teams or the WebEx ID for the continuation of our regular classes. So this yesterday and today what we're using is just a demo link which is publicly available. So will be valid for only these demo classes. And apart from that, we discussed about communication. All the students will be part of the dedicated WhatsApp group, and all the questions, queries, everything will be discussed in the WhatsApp group. And the important fact about this course is regarding the Google Drive access and the WhatsApp group will be like accessible lifetime, and then even after completion of the course, we'll be having an active participation on the WhatsApp group. We'll be discussing any questions, queries, or any extra topics, or any particular WebEx or live sessions will be conducted after discussing internally within the group. Right. So that's about the prerequisites or the important factors about the course what we discussed. And before we commence or begin the course, important factor about the what are the prerequisites for this particular course. So first thing is who can attend this course. As we discussed yesterday, anyone can attend, junior DBA or senior DBA, or you are a subject matter expert or you are Oracle expert. It doesn't matter. Anyone can attend this course because this course is formed such a way that whatever needed for outside world for any client as a RAC administrator, what are the day-to-day activities will be performed. Everything will be combined together and form this particular course. And this course will start from the basics, will go till advanced level. So anyone can attend this course. Doesn't matter whether you are having 1 year experience, 1 year of experience, or 5 years of experience, or 10 years of experience. Doesn't matter. You can attend this course and participate on this course. And the main fundamental, the requirement for this course is you should be knowing a basic architecture of database. You should be knowing fundamentals of database, how database architecture works, and what are the basic core functionality of my Oracle database. All should be aware of that. If you don't know that, probably this RAC course is not fit for you, right? So you have to know the basic knowledge, then only you can continue with the RAC course. If you don't know the basics, then first attend the database course, where we'll be covering the basic knowledge and fundamental architecture of database. And once that is done, go for this RAC course, right? And other important prerequisites is you should have 16 GB RAM and 100 GB SSD. And if you don't have 16 GB RAM, probably you'll not be able to do a lab exercise. You just need to be like rely on me, whatever I'm showing demo, you have to rely on that. You cannot be able to do a labs hands-on experience, because we'll be setting up a lab on individual laptop where minimum requirement is 100 GB SSD. It should be SSD, then only 16 GB RAM will work. If you don't have a SSD, somebody is asking question here, is SSD mandatory? Yes. If you're having 16 GB RAM, then 100 GB SSD is mandatory. And if you don't have SSD, you have normal SATA disk, then your RAM should be more than 16 GB. Minimum should be 24 GB or 32 GB, because 16 GB RAM is a least RAM, which will only work with SSD. And if you don't have SSD, then your RAM should be 24 GB or 32 GB, right? So, but that is the minimum requirement. And if you have more than that, like 32 GB or 24 GB, then that's fair enough, because you can work seamlessly without any delay. With the 16 GB RAM and 100 GB SSD, there is a slight delay. You have to bear with that, because with the 16 GB RAM, the moment you spin up two VMs for the two node rack setup, your laptop will be like almost consumed all the resource. There will be a slight delay, and you have to bear with that and practice slowly. So this is a minimum requirement I'm talking about. 16 GB RAM and 100 GB SSD. It's a mandatory. It's a must. Right. Right. That's what we discussed about this particular course in yesterday's session, and followed by we started with some of the discussion about standalone versus RAC and the different types of databases, and whatever we basically discussed 4 types of databases, and those will be like mandatory architecture which will be available for any client in the market. So whenever you start working on any of the client, so you may end up with any one of those 4 types of database: standalone, Oracle Restart, RAC, and Oracle OneNode. That's what we discussed, and we'll continue, and we'll start with the RAC architecture and networking for today, followed by cluster startup sequence. All right. So any questions so far in our yesterday sessions, or so far whatever we talked, before we proceed for today?
Malik, as I mentioned earlier, I yesterday couldn't join, and how I can communicate with you, and how we will get that WhatsApp link, and that whatever drive link you said, how I
All
can
right.
get them.
We'll cover that quickly. Right. For your question, quickly, what we talked yesterday, these two are the demo sessions. 1st July and 2nd July are the two demo sessions. If I can get my calendar here, July 1st and 2nd, these are the two demo sessions. Whatever the timing we are starting now, 7 a.m. to 9 a.m. IST. That pretty much 9:30 p.m. EST to 11:30 p.m. EST. 2 hours of demo session yesterday and today, and we completed that yesterday's demo session, and this is second demo sessions, and this is the Zoom link what we're using it. And we talked about this RAC course curriculum, and if you can go to my blog, and then we talked about this RAC course curriculum, what is included. I request you to go over that video again, and we talked about this RAC course curriculum. And actual course is gonna starting on next weekend. We are starting on 8th of July. We are starting this actual RAC course on 8th of July. 8th of July, Saturday. So the course will be of 4 hours on Saturday and 4 hours on Sunday. So that is 7 a.m. IST to 11 a.m. IST. That is 9:30 p.m. EST to 1:30 a.m. EST in Eastern Time Zone. So 4 hours on Saturday and 4 hours on Sunday. This is a weekend batch. So this particular RAC course is a weekend batch. Only Saturday and Sunday. Classes are conducted only Saturday and Sunday. And again, same 4 hours on Saturday and Sunday. But in this 4 hours, we'll be having 5 to 10 minutes break after 2 hours. That is a small break, because we cannot stretch 4 hours in one go, right? And duration is going to be 5 weekends. So if you see, if we start on 8th, we'll start with the 8th, that's the first weekend. 15th of July, that's the second weekend. 22nd of July, third weekend. And 29th of July, fourth weekend. and probably 5th of July is 5th of August is the 5th weekend. We will be pretty much able to complete by this 5th and 6th of August. And apart from this, what we talked yesterday, if there is any extra sessions, whatever the course curriculum, you can see it here, we pretty much covered everything. And apart from this, if any particular extra sessions or anyone interested in more of a one particular session, like for example, OEM or Golden Gate or Oracle wallets or Oracle licensing, any advanced session, and based upon the majority of request, we will take 1 or 2 extra sessions, and that pretty much will be followed by 5th of August and 12th of August or 19th of August. We'll take the consecutive weekends and we'll try to cover those extra sessions based upon the request and how many students are interested on that. That's what we talked. And along with that, this particular training is a paid training. The course fees is going to be 15,000 Indian rupees or 185 US dollar, and mode is live classes. It's online, Zoom or WebEx or team will be communicated in that WhatsApp group. And regarding the payment, I requested who are interested by this particular course, try and get in touch with in my WhatsApp number or through my email ID. WhatsApp number as I showed here, +919880616848, or my Gmail ID, mallikarjun.ramadurg@gmail.com. You can ping me or call me on my WhatsApp number or drop me an email. I'll further guide you for the payment processing, how we can do the payment and other stuff. And once you're done with the payment, and you'll be added to WhatsApp group, and all the communication will be happening through that WhatsApp group. And once you register by making a payment, and we'll be getting access on the Google Drive, and where you can see all the course materials. We showed all the Google Drive access yesterday. Request you to go back and watch that yesterday session. Anyway, once you register for this course after making a payment, on 8th of July will be one more time in details going over that Google Drive and showing all the different folders and where all the materials, softwares, and other stuffs are located in the Google Drive. We'll be driving in our actual classes how we can access the Google Drive and all. Right. So yeah, you can get in touch with me in my WhatsApp number, or you can call me on my number, or drop me an email for the payment processing. Anyway, I pinged all my WhatsApp number and email ID in the chat here. Who are interested, you can take a note of that. All right.
No, thank you.
Couple of questions in the chat here. Rahul is asking, please take a note of data guard configuration. Yes, obviously we'll take it as an extra session. We'll be covering at the end of this course, a data guard configuration for standalone or 2-node rack to 2-node rack, how we can do a data guard configuration. There is a different method for data guard configuration. We'll definitely take one session. So since you're asking this question, I request you to please go over this particular document here. I recently posted one particular article in my blog. I request everyone to kindly go through that. It's a brilliant document. The moment you see, will be wondering. Let me quickly get it right. Right. So many people will often get confused or get worried about when it comes to database cloning. If you want to clone your production database to lower environment like TEV, test, or UAT, or when you want to build your data guard, many people will get confused or you don't have idea how to do that. But I request you to just go over this particular document here. I recently posted this one that gonna give you insight about how you can achieve this one. Right, I given 7 options here. So with all the detailed steps I explained with the command line output and all, definitely it's gonna very helpful for you. So what are this one? What this particular document talks about? What are the various methods to build a standby database? You have option 1, option 2, option 3, option 4. And what are the various methods to build or clone your primary production database to lower environment, like development, test, UAT, or you want to build a new environment. You have option 1, 2, 3. You have 3 options. For standby, you have 4 options. For development database build, you have 3 options. What are those? Like build standby database using restore and recover method from primary RMAN backup. And option 2, build standby database using RMAN duplicate. This is a RMAN restore and recover method. This is RMAN duplicate method from primary backup. You have primary backup, use the restore and recover method to build your standby, or use RMAN duplicate method to build your standby database. 2 methods. And third one, build standby database using RMAN active database duplicate from the primary database without backup. These first 2 methods are with RMAN backup. You're taking a primary database RMAN backup. Once you take a primary database RMAN backup, you can build your standby using the restore and recover method or RMAN duplicate method. The option 1 and option 2 depend on your primary database backup. This option 3 and option 4, we don't need a primary database backup. Directly we'll connect to primary database and we'll build standby database. One is RMAN active database duplicate using primary database without backup. And option 4 is build standby database using primary service name without backup. Again, these 2 options are we don't need a backup. One we can use active database duplicate, and one we can use primary service name. This is a 12C new feature. So you have 4 options to build your standby. You can go through all this. I have given in detail option 1, step 1, step 2, step 3, step 4, and how you can build end to end. You can provided over here. I request you to go over that. And anyway, once you go over this one, all your questions and queries regarding the standby will be cleared. And anyway, we can take one demo sessions after the end of this course by just referring this document. Right, that's the answer for your queries, right? Okay, next I'll take one more questions. My laptop is having 8 GB RAM. Definitely, as I said, 8 GB RAM will not work. Minimum we need 16 GB RAM, and you have to either upgrade your laptop to minimum 16 GB RAM and 100 GB minimum SSD hard disk needed. And you can consult any of the service center and then try to upgrade your laptop, or else if it is not possible, request you to buy a new laptop so that you can do a hands-on experience. If you can't offer that one, then still you can attend the course, but you cannot do a hands-on lab. You just need to rely on whatever I'm showing the demo, and you have to watch the videos, and that's it. You cannot do a hands-on. Right.
Okay, sir.
Right. So, one more question: 16 GB RAM and 500 GB HDD. Again, HDD with the 16 GB RAM is the damn slow. We need the hard disk should be SSD if you have a 16 GB RAM. If your hard disk is HDD, your SATA disk, then RAM should be minimum 24 GB or 32 GB. Then only it will be like more powerful and you can work seamlessly. So HDD again 16 GB RAM, it will be damn slow. All right. Any questions, guys, before we proceed further? All right. I'll take it as a no. Let's continue further. Right, so let's continue with we talked about standalone versus RAC yesterday, and we talked about advantages of RAC database over a standalone. That is basically your high availability. And also we talked about different types of databases and their advantages, like standalone database we talked. Let's quickly put them here. We talked about standalone database and Oracle restart. So the basic difference between standalone is single node or server without ASM, right? That's about your standalone. And Oracle Restart is nothing but single node or a single server with ASM. And we talked about RAC and we talked about RAC one node. So this is basically RAC or cluster nodes and multiple instances. Right. Let me, guys, can you go on a mute if you're not talking? All right. And RAC one node is a cluster nodes, multiple nodes, and a single instance. At any given point of time, there's only one instance will be up and running for the RAC one node. We discussed in detail in our yesterday session about this. And these are the types of databases. And we talked about standalone versus RAC. What are the advantages? Right. Now, let's go in deep dive. First, we'll understand the difference of the installation process. What are the different installation process involved in this, and what are the installation changes happen between your 11G, 12C, and 19C. Right. In standalone, like this is your first option, this is your second option, and this is your third database, and this is your fourth types of database. So in standalone, what we do, we directly, the first step, download your Oracle software. We're going to download Oracle software because we're installing only database here. We'll download Oracle software and install Oracle Home. And typically, as I said, we're going to install Oracle Home U01 app Oracle /product /19C /db home _1. And then we're going to create database. Right. So these are the three steps involved when you talk about standalone database. We just download Oracle software and we'll install Oracle software. That's your Oracle Home. Typically, this is your Oracle Home. And on top of this Oracle Home, we'll install we'll create the database. And if I quickly go to my lab here, this is my Oracle Lab 1, where we have this standalone database. Right, this is my DBDB database. And if I check my Vara tab entry, Vara tab is a file where you can have your Oracle Home details. So we have this DBDB. This is a software. I can go here and do ls. And this is a database software. And that's what I just copied this from here, right? So you basically download. Again, we'll discuss in details how to download, where to download all the softwares in our regular classes. We basically download it from Oracle eDelivery or support.oracle.com. Any of those sites, we'll go and download the software. We'll discuss in details about that. These are the three steps in order to create your standalone server. We basically download the software and we'll install Oracle Home. Whatever the downloaded software, we'll unzip and we'll install the Oracle Home. For installation, we basically use run installer. This is the tool. We use this run installer tool. And with the help of this run installer tool, we'll install the Oracle Home. And we'll create a database with a tool called DBCA, Database Configuration Assistant. We'll run like /run installer /dbca. So that's gonna your standalone setup. Right. For Oracle restart, what we do, the same process. I'll just copy all the steps. It's the remain same. download Oracle software, download Oracle Home. So download Oracle software and install your Oracle Home using run installer and create your database using DBCA. The same step, but Oracle restart is with ASM. Before you do this database installation, you have to install ASM. For that, before this, there the two more steps will come into picture here. One is, instead of Oracle software here, we're gonna download, instead of Oracle, we're gonna download ASM software or grid infrastructure software. We call it as the ASM software or grid infrastructure software or your clusterware software. You can call it as anything. So we'll download GI or ASM software and we install ASM or GI home. So typically we install in U01 app 19C grid. So this is your typical grid home or the ASM home. And to do this setup, we use a tool called grid setup.sh. Right? So we do the same thing. We'll download the GI software because it's a single node. On the single node, we'll download the GI software. We install the GI software using this tool grid setup.sh, and we'll download Oracle software. We install Oracle Home using this run installer, and we'll create a database using DBCA. Right? That's your Oracle restart installation. Right. Coming to RAC node. This is a multiple node, 2 node, 3 node, 4 node, 5 node, right? But here advantage, let's say I have a 2 node rack, node 1 and node 2. So I'm doing 2 node rack setup, and exactly steps are same what we're doing here. All the steps same applicable over here. What we're going to do, you have a let's say I can say 4 node rack, node 1, node 2, node 3 and node 4. I'm trying to set up 4 node cluster here. RAC database is a cluster, right? I'm trying to do 4 node cluster. What I'm going to do, download ASM or GI software only on node 1. I'm going to download, remember this is very important step. We'll download GI software only on node 1 and install that ASM and GI software using this grid setup on node 1, only on node 1. Once I download the software, I'll run this one. You're going to install software on node 1, and as part of that, what you're going to do, it automatically copies this GI or ASM software to all other cluster nodes. We no need to install this grid software on all the 4 nodes. Just run this grid setup on node 1 and it'll ask you to select all the cluster nodes. You have to just check box node 1, node 2, node 3, node 4, and then just submit it. It'll automatically copy that ASM or GI software to all other cluster nodes. The steps remain same, whatever these 5 steps remain same, but internally it'll automatically copy that software. We no need to do anything on that. Same thing goes for Oracle Home installation. You just need to download Oracle software only on node 1. You no need to do it on the other nodes. And after that, you're going to run that run installer. And the moment you install this Oracle Home using run installer on node 1, we're going to do this only on node 1. We are not going to do it on all the nodes. Right? The moment you do this run installer on node 1, and you no need to worry again, automatically you're going to copy everything on all other nodes. It automatically copies, not a GI here, it's a Oracle Home. Oracle Home software on all other cluster nodes. And later create database, run DBCA on any node, not necessarily on node 1 or node 2 or node 3. Any node you can run it. on any node. Right? At the moment you run this one, it'll ask you to do which database you want to install, whether you want to install RAC database or RAC one node database. So here also the steps remain same. Just copy this all the steps and paste it over here. This RAC database installation or RAC one node installation, the steps are remain same, but only thing the last step is going to change here. Run the DBC on any node, run the DBC on any node, and select what type of database you want. Right? What type of database you want? You want RAC database or you want RAC one node database? That's the only difference. Right? If you select multiple nodes here, it will become a RAC node. And here, if you select only one node, that will become your Oracle restart. While running this DBCA, it will list all the 4 nodes. And if you select all the 4 nodes, it become a RAC database. If you select only one node, it become a RAC one node. Right? That's the only changes when you run your DBCA. Otherwise, step number 3 and 4, RAC database installation or RAC one node installation, it remains same. Only this DBCA will decide whether it's a RAC database or RAC one node database. The moment you run the DBCA, it lists out all the 4 nodes. And if you select all the 4 nodes, RAC database will be created on all the 4 nodes. If you select only 2 nodes, RAC database will be created on 2 nodes. And 2 nodes, no database instances. Only instance 1 and 2 will be selected here. That's what we discussed yesterday in this slide right here. Where is that one? Okay, this one here. So DB, it is having 2 node here. Even though it's a node 1, 2, 3, 4, 5, it's a 5 node cluster, but your DB is created on only 2 nodes. Other 3 nodes is not created. How it is possible? The moment you run the DBCA here, it will give you all the 4 nodes, but you're going to select only node 1 and 2. And your DB database will create only a node 1 and 2. It's a RAC database. If anything other more than one instance, it's a RAC database. But whereas in RAC one node, you will run the DBCA, but you're going to select only one instance. So it's going to start only one instance. Remaining all, it's going to make it as a standby. Not a standby, like, the secondary type of instances. When that node goes down, automatically other node will be up. Right. So that is your how you can install these 4 types of databases. Any questions so far? Right. I'll take it as a no. Proceed further. We understood now how we can install these 4 types of database. Whatever the 4 types of database what we talked yesterday, we understood how we can accomplish the installation. And now what are the changes in installation across the version, across 11G, 12C, and 19C? There are a lot of differences in the installation steps in 11G, 12C, and 19C. And starting with the 19C, it's all static. 19C, 21C, and there's a lot of difference between 11G installation, 12C installation, and 19C installation. And starting with your 19C and 21C and 23C, all the installations are same. So there are a lot of changes happen between 11G to 12C to 19C. But starting with the 19C, it will all become constant. What are those? Let's see here. 11G, I'll talk about the GI installation first. In 11G, what happens? Download the GI software. You basically need to download your GI software under like U01 patches. You will download your software under U01 or somewhere, some temporary directory. You will download the software, GI software and some temporary directory, and you are going to unzip that software on that temporary directory. Use your own patches. For example, let's say I'll take it over here. Like in 11G, you downloaded your GI software. Like, you can say U01 patches. You downloaded your GI software, that is like gi.zip. So you downloaded your GI software and you're going to unzip that GI software. It'll become U01 patches and then GI. First, you're going to download that zip software, GI software, and you're going to unzip that one. It's going to create that GI directory. And from there, right, from there, you're going to run the run installer. So there's a difference here. If you see, you are going to run the run installer. So far, I talked about here. If you observe my GI installation here, I talked about a grid setup that is applicable for your 19C. But in 11G, there's nothing called grid setup. In 11G, it is again your run installer. You are going to go inside that GI, and from that GI, you're going to run the run installer.
What about in 12C, Malik?
I'm going to explain. I'm coming that one. Right, you're going to run the run installer. The moment you run this run installer, it used to ask where you want me to install the GI software. This is the patch. You unzip the patch and you run the run installer. It used to ask where you want me to install the GI software, and that's where you need to give this path where you want to install your GI software. And the moment you give this path, you're going to install the GI software on this directory. Right, that is for your 11G. And what happened to the 12C? Download the GI software and you're gonna unzip the GI software. But here the problem with the 12C onwards, I'll just copy it. In 12C, you are going to, this is your download. Download GI. I can say software. And unzip GI software. And then install GI or ASM home. So you can make it as GI or ASM. We'll talk when to call GI, when to call ASM home on our regular classes. But for now, you can assume GI or ASM are one and same. So we're going to download the GI software. Remember, download the GI software on some staging location. Right? We're going to download the GI software on the staging location. And unzip the GI software on staging location. Staging location in the sense some dummy locations. Right, the moment you run the installer using this run installer, it will ask you to where I can install the GI software. But in 11G, there's nothing called staging software. You have to download software, download GI and ASM software on your actual location, actual GI home or location. It means you're going to download and place it under actual GI home. So my GI home is this one, U01 app 12C grid is my actual GI home. I'll directly download it over there. U01 app, I'll just make 12.0.0 just to make it simplify. U01 app 12C grid home. I'm not downloading it on some dummy location. Directly on my GI home where I want to create, there itself I am downloading it there. And after that, unzip my GI software. Unzip GI software. Unzip GI software on actual location. Wherever I placed my actual GI location, there itself I'm unzipping here. And install GI home. Install GI or ASM home using grid setup here, not a run installer. I'm using a grid setup. So this is my GI, and where is that one? I'll go here and I'm going to directly run grid setup.sh. Not a run installer. I'm running the grid setup here, and it will not ask you to where I want to install. Here in 11G, what used to do, the moment you run this run installer, it used to ask you where you want me to install this GI software. Right? The moment you run this, it will ask you to where you want me to install the GI software. Then you need to pass actual GI home, GI or ASM home location. Typically your 11G. Use your own app. It's a 11G or 11.2. I'm just making it a simplify here. So then it used to copy from this use your own patches, whatever the GI temporary location, to this actual location. But whereas in 12C, there's nothing temporary location here. You are going to directly download the GI software under actual GI home where you want to configure, and you're going to unzip that GI software under actual location where you want to configure your GI or ASM home, and you are going to run that grid setup.sh. It will not ask you to where I want to install. The moment you run the grid setup.sh, it assumes, okay, this is your actual GI home. I'm going to configure that as a GI home. So that's the understanding here. By mistakenly, if you download your 12C software or 19C software, like here in this particular location, GI home, right? If you download your 12C software under use your own patches, GI, and you're going to unzip over there. And after that, you're going to run the grid setup.sh. What you're going to do, the moment you run the grid setup.sh, your use your own patches GI, this become your actual GI home and the ASM home. So very careful between 11G and 12C. 11G, we need a temporary staging location to unzip your GI software. But whereas 12C, we don't need the temporary location. Directly, we're going to unzip the software into my actual GI home location. And from there itself, we're going to run the grid setup. It will automatically makes that location as a GI home. And same thing goes for your 19C. Download the GI software, and you're going to directly download it under actual GI home, and you're going to unzip under actual GI home, and you're going to run the grid setup.sh. Automatically, that where you unzipped, that itself will become your GI home. Your 12C and 19C GI home installation remains same, and your 21C, 23C remains same. Your GI home, the installation process is remain same here. So your 19C or 21C or 23C or all same here. I can just say 12C, 12C, 19C, 21C, and 23C GI or ASM home installation are all same, right? So that's a major difference in GI installation. From 11G to 12C, there's a major difference happened, and after that 12C onwards, it's all remain same. Going forward, it remains same, whatever I just explained. This is for GI. Let's go for Oracle home. In 11G, same thing. Download the DB software into temporary location, run the run installer, And then it used to ask where you want me to install the DB software. You're going to give that 11G Oracle home. It used to install, copy that software to that new home, and it used to create that Oracle home there. 11G and 12C are remain same. Download the 12C software, and after downloading into temporary location, you're going to run the run installer, and then it used to ask where you want me to copy or install that 12C Oracle home. You're going to give that Oracle home, and it used to copy from the temporary location to the actual Oracle home, and then Oracle home is ready. But whereas in 19C, it's not like that. Download the DB software. Where you want to download? Download directly into your 19C Oracle home. Where you want to configure 19C Oracle home, download directly into that particular Oracle home. And after that, run the run installer. The moment run the run installer, it will not ask you to where you want me to install. It will assume that, okay, whatever the location you unzip the software, that itself is Oracle home. I'll make it as the Oracle home and directly install it. Right? So you downloaded under 19C Oracle home, and the moment you run the run installer, that 19C Oracle home become actual Oracle home. So your 11G and 12C are remain same. Temporarily, first you're downloading on some staging location. From there, you're going to run the run installer. The moment you run the run installer, it used to ask where you want me to install actual Oracle home. You need to pass this path locations, and it used to copy from the staging location to actual Oracle home, and then it used to make that as a Oracle home. Whereas in 19C onwards, you are directly downloading the software into your 19C Oracle home, which is your actual Oracle home path. You're going to download it over there, unzip over there, and the moment you run the run installer, it used to convert where you unzip that location. It used to convert that as a Oracle home. And your 19C, 21C, and 23C are remain same. Your 11G and 12C Oracle home installations are same, which involves staging location. From staging, it basically staging to actual Oracle home. Right. So it involves staging location. You have to unzip that staging location, run the run installer. So there is no changes in the utility. It's all run installer. Oracle home, it's all run installer. Whereas GI in 11G, it's the run installer. Starting with the 12C, it has got changed to grid setup. Whereas in Oracle home, it's all run installer. Even it is 11G, 12C, 19C, 21C, 23C, it's all run installer, but the way of installation got changed. In 11G and 12C, we used to first download and unzip under staging location. From there, we used to run the run installer. It used to ask, what is your actual home, so that I can copy it. In 19C, 21C, and 23C, it's all same. There's no staging location. It's actually actual Oracle home. You're going to download it, download the software under actual Oracle home, and you're going to unzip from there under actual Oracle home, and from there you're going to run the run installer. The moment to run the run installer, that internally makes it as a Oracle home, right? So that's a installation changes what you see from between 11G to 12C to 19C, and 19C onwards, it's all remains same across your Oracle home or the GI home installation. This is remain same between 19C, 21C, and 23C. Going forward, it's remain same like this, right? That is for your the installation changes. Let's now continue further. If no questions here on the installation part, right? We'll take it a little later. Now let's go for the RAC installation. Right? Any questions, guys, so far? And networking. Right. Again, as I said, right, what is GI here? We'll talk about that. Some questions in the chart here. What is GI? GI stands for grid infrastructure. we have a different terminologies. If I want to make you, GI is one terminology, grid infrastructure. Cluster is other terminology. Clusterware software. And ASM home is other terminology. And Oracle home, Oracle software, Oracle binaries. There's so many terminologies will come into picture. We'll talk or we'll discuss in our regular classes. Right. Right. So let's single understanding about the clusterware. We'll talk about now on the RAC architecture or the clusterware architecture. RAC stands for Real Application Cluster. So we'll try to understand this RAC architecture and the networking in the RAC. Right. I'll just take my note paint. Right. I want to do a 2-node RAC setup. Right. I want to do 2-node RAC setup. We already discussed how to install the RAC. We already discussed here RAC 1-node or RAC setup. We are going to download GI software on node 1 and we're going to install it. So the moment I install it, it become plus ASM 1. And let's say I can simplicity, I can just make /u01 and 19C and GI. So I install my ASM home on node 1. The moment I install my ASM home or the GI home on node 1, automatically, as I said, the software will be get copied here. That will become your ASM2. You have ASM1 and ASM2, your 19C GI home, 19C GI home. So the home is going to be remain same across all the cluster node. If you make U01 19C GI, automatically on the second node also it will copy on the same location, U01 19C GI. Quickly on my lab here, I have this node 1, PS-EF grep smon, and I have my ASM1 on node 1, on the node 2, PS-EF grep smon. I have my, it's again node 1. Let's go to node 2. Right, this is my node 2. Right, I have node 1 here. Right, node 1, I have ASM1. So my ASM home will be U01 app 19C GI. So this is my GI home. I installed under this location. And on node 2, it's remain same. On node 2 also, the home is going to be remain same. This is my GI home here. LS. So automatically, I'm not installing it on node 2. I'm just installing it on node 1. Automatically, it's going to copy it on the other node. So my GI home is got installed here. So that's why I mentioned ASM home 1 here, ASM instance 1 here, ASM instance 2 here, and my ASM home or the GI home is remain same across all the cluster nodes 1 and 2, right? And now I install ORCL1 and I'll simply say U01 app 19C db home _1, right? So that is my Oracle instance 1 and I installed Oracle home here. I'll just make like this. It's Oracle instance 2. Right. If I go back here, I have Oracle instance 2, which is installed under U01 app Oracle product 19C DB home, right? So this is my Oracle home, U01 app Oracle product 19C DB home on node 2, where my instance 2 is running. If I go to my node 1, and node 1 also remains same Oracle home, ps-ef grep smon. I have my Oracle instance 1 here. The Oracle home is remains same, U01 app Oracle product 19C DB home 1. Right, this is my Oracle home here, and we have this run installer. And again, if I can go back here, how we can install Oracle home? Download your software only on node 1 and install your Oracle home by running this run installer on node 1, and it automatically copies that software to all the cluster nodes on the same location. I have done it on node 1, automatically it copied on the other node, and it created my Oracle home, same location. That's where I mentioned here, the home will be remain same, U01 app 19C DB home, U01 app 19C DB home. Your instance will get changed, instance 1 and instance 2. If you have 3 node, remain same. Right, so this is your typical 2 node cluster. It's gonna form you 2 node RAC cluster. For this one, to make it, who is responsible for making this cluster? Node 1 and node 2, how it become together as a cluster? This become your cluster now. This become his cluster. Who is making responsible for the making this as a cluster? Your GI software, whatever we installed, that is responsible for making it as a cluster. Right, so how we're gonna make this GI software is a combination of ASM home, right, and then sorry. Okay, your GI, we used to call it as GI, right? Grid infrastructure. Whatever this ASM home, we are calling it as a GI, grid infrastructure. What is this GI? GI is basically combination of ASM home and your clusterware home. What that mean? In as of 11G, we used to install first clusterware. Like let's say I have my node 1 and I have my, so not of as of 11G, as of 10G. Let's say here, I'm just talking about in 11G, not 11G, so 10G. In 10G, what we used to do, you want to configure 2 node rack. You want to configure 2 node rack. What we used to do it in older days, in 10G and prior to 10G. We need to first download cluster software. First is cluster software. We used to download cluster software and install U01 app cluster. We used to download U01 app cluster on node 1 and node 2. Right, on node 1, we used to download this cluster software. On node 1, we used to install U01 app cluster and U01 app cluster. And the moment I install this cluster software, it used to become your 2 node combining together cluster. The separate software to make it as a cluster. That is fair enough. And now, after that, what we used to do? We used to install ASM home. ASM software. ASM software for what? I discussed yesterday, right? ASM is act as a storage mediator. It's gonna give you storage capability. Right? You have to install Oracle ORCL1 and ORCL2, where your data files are going to store. And if I get my yesterday's notepad here, we talked about this one, right? In your Oracle Lab 1, all the data files will be under local file system. If it's a ASM, all the file system will be under your disk groups, ASM disk groups. That is act as a storage. So in 10G, we used to install ASM software like U01 app ASM underscore home, or just make ASM. And our node 2 also remains same. We used to install your ASM. So first software is a cluster software. We used to install it to make it as a 2-node cluster. And once the cluster is ready, we used to install ASM software on node 1 and node 2 to provide the ASM, that storage feature. And after that, your databases, DB software. We used to download the DB software and install the DB software. U01 app. I'm just giving a dummy name here, DB home. And the same thing for your node 2 as well. Also, I'll make it here. Right. Also, I'll make it over here and a little bit here. Right. So you install DB home and you install DB home. And after that, you're going to create the databases. So we used to install 3 software as of 10G. Right. So a clusterware software, separate software, ASM software, separate software. Clusterware software is to make 2-node cluster, 3-node cluster, combine all the cluster, the nodes together and make it as a cluster. And ASM software to provide that ASM storage, disk groups, data, RICO, FRA, disk group. So to place your database. And database software for create and configure your database instances. We used to install 3 software. But in 11G, what they did, Oracle, why to install 2 software, clusterware software and ASM software separately and make the installation process tedious? Instead of that, let's go with only one software. That is GI, grid infrastructure software. Grid infrastructure is nothing but your ASM home and clusterware home. Whatever this cluster software and ASM software, they combine together and they call it as a GI software, grid infrastructure software. And now what we're doing, we are just installing only one GI software. Like, we'll install it on node 1, U01 app, and we make it as a grid or the GI. You can give whatever name you want. Right. So the moment you install GI software on node 1 and the moment you install it on node 1, automatically it'll install it on node 2. What it's going to do, the moment you install the GI software, you are basically installing 2 softwares. One is a cluster software and other one is a ASM software. The home is remain same. So U01 app grid is a GI home, grid infrastructure home. Some people will call it as a GI home, or some people will call it as a clusterware home. Some people will call it as a ASM home. Yes, that's true. All 3 words are remain same. Clusterware home also is remain same. ASM home is also remain same. GI home is also remain same. All are one and same, because GI is nothing but combination of your ASM and cluster now, starting with your 11G. And after that, second step is your DB home, DB software. And you're going to install the DB software here. Same process, U01 app DB home. So that's a installation changes happened between your 11G to, I'll just make it over here. That's a major changes between your 11G to 10G to 11G. 10G we used to install 3 softwares, and in 11G Oracle made it as only 2 software. GI is a combination of your cluster and database. The many people, if they call it as a GI home, grid infrastructure home, or ASM home, or a clusterware home, all are one and same here. Now going forward after 11G, it's all remains same. Right. So that's changes. Now let's go back here. Now we install ASM the moment you install ASM, it means GI you install grid infrastructure that made it as a cluster, and also your ASM home is ready. And on top of that, you created your Oracle home. Once this cluster is ready, and once you set up your Oracle home and Oracle database are ready, there are a lot of networking will come into picture here. To do this setup, to do this installation, I just said download the GI software and install it. But to do that installation, you have to do a lot of pre-checks and post-checks, and you have to understand a lot of networking, which will be plays very, very important role. So that we're going to talk about now. Let's go here. I'll take a new one. Right. Let's say I'll just make it as a 2 node. Right. I'm just gonna make it as a plus ASM1 and ORCL1. You did a setup of 2 node RAC ASM2 and Oracle instance 2 now. As I said, installation is as simple as that, running that grid setup and running that run installer, it's gonna make you. But before that, you have to make a lot of changes on this particular, lot of pre-checks you have to do it, lot of networking setup you have to do it. Okay. In order to do this one, node 1 and node 2, the very first thing, 2 network will come into picture. I'll make a green color, public network, and I'll make red color a private network. Public network and private network. The name itself indicates public network. It means publicly available. Outside of your domain, anyone can access. Like if I say your domain, let's say oracle.com. Oracle.com is your domain. Or you can say infosys.com or tcs.com or wipro.com. Any domain, they have whatever the domain. Within their domain, I have one server and I have other server. Within the server, if they want to communicate, they can directly use a private network and they can communicate. The same server, whatever in their domain, if they want to communicate from outside network, outside of their domain, they have to go with a public IP. This particular host will be having one interface with the public network and one more interface with the private network. So the public network will be accessible from the outside of the domain, outside of their network, anyone can access that one. That's your public network. And the private network is within their domain, anyone can communicate. That's a private network. So these are the 2 types of network you can typically see it. One is a public network and another one is a private network. Private is within their domain, within their infrastructure. Right. For the RAC setup, we need these 2 types of networking. We need both public network, we need both private network. We need both this public and private network in order to do this 2 node RAC setup. Right. I'll just take the host name. This is my host name. Node 1 and node 2. I have node 1 and node 2. I have 2 nodes. And these 2 nodes, this is the actual host name. And this actual host name will be having, this is the, okay, before that, public network, we understood, private network, we understood. Public network is outside of their domain, they're able to access it. Private means within the domain, they can able to access it. Now let's understand two more concepts. One is physical IP and then VIP, virtual IP. Physical IP and virtual IP, both are IP. Any server will be given with the IP address, right? So we have something called physical IP and we have something called virtual IP. The physical IP is nothing but IP address assigned to NIC or interface. That's a simple understanding. Any IP assigned to a NIC card or the interface is called a physical IP, and virtual IP does not have any NIC card. NIC or interface. That's a simple understanding. Physical IP and the virtual IP. Physical IP is assigned to a NIC card and virtual IP does not have NIC card. The physical IP may be in public network or in private network. Virtual IP may be in public network and private network, doesn't matter. Right? So your public IP also will be having physical IPs and VIPs. And your private network also might be having physical IPs and VIPs. There's just two types of IPs. One is the physical IPs and private IPs. So physical IPs and virtual IPs. Physical IPs are assigned to NIC card and VIPs are not assigned to NIC card. That will be like floating. That will be like hanging. And these physical IP and virtual IP also available in public network, also available in your private network. Doesn't matter. Right, now we understood this physical IP and the virtual IP. Physical IP is assigned to a NIC card and virtual IP is not assigned to a NIC card. What I'll do now, I'll go to my lab server and node 1, I'll do ifconfig. So these are called my NIC cards or the interfaces. And let's see here. ENS 192. I have one NIC card. I'll just make it as one NIC card here, ENS 192. And now again ENS 192, ENS 192, ENS 192. And now you can see ENS 224, one more NIC card. Two NIC cards. And then I'm not worrying about, this is my actual primary NIC card and remaining all like :1, :2, :3. These are called your VLANing or pegging. So we don't worry about this. Actual NIC card is this one without any suffix here. So this is your interface on node 1 and which is having this particular IP. Just copy this one. Right, this is your interface 1 having this particular IP address. And then go down, you have interface 2 and having this particular IP address. Right, we got it now. So like again, understand by this definition, physical IP is what? Assigned to NIC card. So my ENS 192, ENS 224, both are NIC cards and two IPs are assigned. And what is this IP then? This IP we can call it as a physical IP. Yes, definitely we can call it as a physical IP because assigned to a NIC card. So I can say this particular IP is a physical IP. Right, and what about this one? Again, that is also assigned to your NIC card. That is also your physical IP. Fair enough. And what is this virtual IP? Does not have any NIC card. Let's go here. Whatever this interface with this :1, :2, :3, and still we have these IP addresses. I have IP address 1, I have IP address 2, and I have IP address 3. I have 3 IP addresses and which does not have any NIC card. you can see they are just hanging on the existing NIC card. So this is your NIC card, actual NIC card. With that, it's going to do VLANing here. So :1, :2, :3. So these IPs are your VIPs, the virtual IPs, which does not have any of its own NIC card. It will be just hanging with any existing NIC card with the VLANing. So I have one IP address. I'll just take a note of that for now. Right, I'll just take a note of that. I have got one IP address here, :1, :2. I have one more IP address. And then I have :3, one more IP address. So I got a 3 IP address on node 1. Okay, that's fine. Let's go to second node. Right, I got this 3 IP address, which are VIPs I'm talking about. And the second node now, IF config. So again, same process. I have one interface, one IP address, physical IP. I'll just put it on the second interface here. Right, and then I got the IP address is this one. I'll put that IP address. Right, and then let's go to the second interface here, ENS 224. And I got one more IP address for that one. Right. Once again, one IP address, and this is one more IP address. Right, what are these two IP addresses now again? Same physical IPs, because those are pegged. Those are actually having interface. So I just make it as a physical IP. Right. Physical IPs. Now I got it. I got a physical IP of node 1, and again I got a physical IP of node 2. Node 1 physical IP, node 1 physical IP, again node 1 physical IP, node 1 physical IP. I got physical IP of node 1 and node 2. And then :1, :1, :2. Again, 2 more VIPs. So I'll just make a note of this. One VIP here and one VIP here. Right. I got all the VIPs here. And here I need to understand which is my public IP and which is my private IP. Right? If I see physical IP correct, physical IP is correct. But if you observe here, it's a 4 dot series and it is a 9 dot series. And here it is 4 dot series and here it is 9 dot series. So both are physical IPs on node 1. Again, both are physical IPs on node 2. But in these two, one will be your public IP and one will be your private IP. And you can easily identify by just trying to access from outside of your network. Whichever is accessible, it's a public IP, and whichever is not accessible, whichever is accessible outside of your domain is a public IP. Whichever not accessible, it's a private IP. So either you directly go out of your VPN or go out of your domain and try to access, and whichever is accessible, you can say public IP. Whichever is not accessible, it's a private IP. Or you can just consult with your network, which one is a public network, 4 dot is a public network, or 9 dot is a public network, or 4 dot is a private network, or 9 dot is a private network. Just check with your network team, they will confirm you. Or other way to confirm is check for your VIPs. Your VIPs, whatever the VIPs you're seeing it here, are all public network. So whatever the 4 dot series, so see these many VIPs I'm having it here. Okay, these many VIPs are means 4 dot series is my public network. So I can easily say my physical IP, this is my public network. And whatever this 9 dot is my physical IP, even though it's a physical IP, but this is your private IP. I can say private IP or private physical IP. You can call it as whatever it is. I can just say private IP. Even though it's a physical IP and also it's a private IP. So even though it's a physical IP, it's a public IP. Right? That's a simple understanding. So basically to do a rack setup, I need two physical IPs or two public IPs. We got two IPs here now, and we need two private IPs. We got two private IPs. And also on the same public network, we need both node 1 and node 2 VIPs. Node VIP. Node VIP. That node VIP on this particular node 1, and also same thing on node 2. Node VIP. We need one set of node VIP. The node 1 also need one VIP. Node 2 also need one VIP. Let's say node VIP I needed here, and similarly for my second node also I need one node VIP. So in this particular 5 IPs here, whatever you are seeing, this 5 IPs, 2 are the VIPs of node 1 and node 2, and 3 of them are your scan IPs. Right, let's go here. My node 1, 192, I'll just put it over here. There's other way to identify which is a node VIP and all. For now, I know that what's the node IP, I can directly put it over here. Node 1, 190, and 190. and 191. Right. These are your node specific VIP. The moment you see your installation guide or installation configuration or the network admin or your etc host files, and you will be able to get to know that two public IPs, node 1, node 2, 182, 183. So whatever you're seeing 182 and 183, those are your physical IP or the public IP. You can call it as whatever you want. I'll just make this one set of IPs. This is your one set of IPs. You need a two physical IPs or the public IPs for each node, node 1 and node 2. Whatever you're seeing here, node 1, node 2, node 1 and node 2, 182, 183. These are your two public IPs which are assigned for two nodes, which is having a physical interface. If I do ifconfig one more time here, and you can see here the physical interface, whatever the NIC cards, whatever the IP is assigned, that is your public IP or the physical IP of that node. That's fair enough. And the second IP what we got is a node VIP of that particular node. So you can check with your network admin or you can check with your installation guide and identify your node specific VIP which is used for your configuration. So 190 and 191 is a node VIP for node 1 and node 2. And these are called VIPs. What is VIPs here? Virtual IP does not have any NIC cards, but they will be hanging or pegging to your actual interface. And if I go here node 2, and if I go further down, 191, it is under 4 series. It's a public series, and public series is what? 192 4 is your public series. For this interface, they will be pegging or VLANing with this :1, and it is on node 2, 191, and similarly on node 1, the same node 1 VIP will be again pegged to that particular interface. 192 is a node 1 interface, 4.182, and 190 is the VIP of that node 1, which will be pegging with this :1. So that is your node VIP, node 1 VIP and node 2 VIP. We got two VIPs of node 1 and node 2, right? And now we also identified the virtual IP of that particular node 1 and node 2. Node 1 virtual IP, node 2 virtual IP. Again, this is under different network and this is under different subnet here, 9 dot series. You can see this is 9 dot series. That's your 9 dot series. So now we got a 3 IPs, a node IP, or the public IP. We can call it as a node IP or the public IP. We basically in general words, we call it as a node IP or public IP. That is one IP we need it. Whatever you're seeing here, this is node IP or the physical IP. Node IP or public IP or physical IP. We call it as a whatever generic words. For one node, we need node IP, or you can call it as a public IP, or you can call it as a physical IP. That's the first one IP we need it. And second IP, what we need? Node VIP. We need node VIP for that node. And third IP, what we need? We need the private IP. We basically call it as a private IP. Again, even private IP is nothing but physical IP. We cannot call it as a physical IP for private IP because we already called here physical IP for the node 1. So that's the reason they will not, even though you can call it in general word, you can call it as a physical IP, doesn't matter. But we basically don't call that. We just make it as a unique. We make it as a private IP for that different subnet, and we make it as a node VIP, which is like VIP of that node. And one is your public IP. We just make it as a physical IP. So these are the three unique general terminology we can use it when it comes to RAC. I need one physical IP for a node, and I need one VIP for a node, and I need one private IP for a node. For each node, I basically need 3 IPs. So you have to work with your network admin, get these 3 IPs in order to do this RAC setup. So in this case, 182, 190 are my physical IP and the node VIP for the node, and 9.182 is my virtual IP. Sorry, the private IP for that node 1. And the same three things for the other node. We call it as a physical IP and node VIP and private IP. So again, these are the 3 IPs for your second node. So we identified 4.182 is my physical IP, and 4.191 is my VIP, and 9.183 is my private IP. So 3 IPs for node 1 and 3 IPs for node 2. So now we got it. 192 is node VIP, and again 191 is node VIP. What about these three? 195, 196, 192. We got 3 more IPs. That is again VIPs. We got 3 more IPs, and these 3 IPs are nothing but your scan IPs. These are your scan IPs. So how I can identify all together in node 1, I'll just do .inv plus ASM1 CRSCTL stat resource -t. The moment I do this CRSCTL stat resource -t, I can say scan 1, scan 2, scan 3. I said 3 are the scan IPs. These are my scan VIPs. So out of this scan 3 IPs, and if you identify scan 1, scan 2, scan 3, 3 IPs, how they spread? 1 is under node 2, and 2 and 3 are under node 1. So now with this calculation, out of this scan VIP, we got to know node 1 and node 2. So this scan VIPs, scan 1 is on node 2, 1 IP I have it on node 2, and 2 IP I have it on node 1. Right, we got it. One IP is on node 2 and two IPs are node 1. And let's go here. Node 1 VIP, node 2 VIP. I have two VIPs, and those two VIPs, one is on node 1 and one is on node 2. So one IP on node 1 and one IP on node 2. So which identifies now totally 1 plus, okay, this is 1. So now sum up one scan and one node VIP. I have two VIPs, totally two VIPs on node 2, and 2 plus 1, totally 3 VIPs on node 1. So that's what we identified here. The moment I do if config, let's remove this. Okay, what we identified here, :1, :2, :3. I got 3 VIPs on node 1. That's where the count is matching here. 2 scan VIPs and one is node particular VIPs. 2 plus 1, 3 VIPs on node 1. That's where you're seeing this :1, :2, :3. 3 VIPs on node 1. On node 2, I got 2 VIPs. One is scan VIP and one is node VIP. Give me a second. There are some guys are using annotation here. Okay. Right. Now we got 2 VIPs on node 2. I'll go to node 2 and do ifconfig and we'll verify those 2 IPs. Okay. Now if I do ifconfig here one more time. Right. :1, :2. 191 node VIP and 192 your scan VIP. One VIP for scan, one VIP for node particular IP. So we got 2 IPs here. So that is why you can identify using your. Now I directly told these 3 are my scan VIPs. How I told that scan VIPs? You have this command, you can run it and you can identify srvctl config scan. That also will give you srvctl config scan. srvctl config scan will give you, okay, these are my scan. I have scan 1, scan 2, scan 3, 192, 195, 196 are my 3 scan IPs. That's where I put all these scan VIPs, 195, 196, 192. Out of these 5 IPs, whatever we listed here, and remaining these 3 are scanned, remaining 2 are your node VIPs, node 1 and node 2 VIPs. Easily you can identify with that. Right, this is one command. Give me a second. Right. So now we got srvctl config scan, and they're going to give me, again, there are so many other commands. Once we start our actual class, we'll get to know that. This is like, layman term, how we can identify which are my VIPs, which are my public IPs, which are my private IPs. So just by looking at the host, just by running ifconfig, I can able to identify which is my public IP, which is my private IP, which is my node IP, which is my node VIP, and which is my scan IP. That is one way to identify. Other way to identify is srvctl config scan, srvctl config VIP. That will directly give you. You no need to struggle all of them. So that command will be like comes into picture once you understand the architecture. Once you're able to, get a hands-on and then understand the core fundamental of RAC and networking. And by running this command, you can easily identify what are my scan, what are my VIPs, what are my node IPs. Right. Otherwise, you have to struggle a lot to get identified all of them. Right. Now we understood to do a 2-node rack setup, how many minimum IPs are needed? 1, 2, 3. 3 IPs for node 1. 1, 2, 3. 3 IPs for node 2 and 3 IPs for scan. Totally, we need 9 IPs for my 2-node rack setup. If I want to add one more node, I need 3 more IPs. If I add one more node to my cluster, again I need 3 more IPs. Each node will be minimum required with the 3 IPs. One is physical IP, one is node VIP, one is a private IP. Physical, VIP and private IP. 3 IPs for each node. Again, physical IP, node VIP and private IP. Again, if you add one more node, again you need a 3 more nodes. So for 2 node rack, 3 plus 3, 3 scan, 9. If you want to do a 3 node rack, 3 plus 3 plus 3, 9 plus 3 scan, 12. If you want to do a 4 node rack, 3 plus 3 plus 3 plus 3, 12 plus 3, your scan, 15. So that's a multiplication of 3 each node we needed with the 3 IPs. And again, for a node, 3 are mandatory. For node 1, I need this physical, VIP and private IP, 3 IPs. But scan, you can run it to only single IP or 2 IPs or 3 IPs, 4, 5, 6, 7. You can go with the scan, no limitation. You can go with the one single IP also fine, 2 IP also fine, 3 IP also fine, 10 IP also fine. But mandatorily or the not mandatorily, you can go with whatever IP you want for the scan, 1 or 2 or 3. We'll explain why we want to go with the multiple for the scan. There's something called load balancing and high availability. Scan will provide 2 features. One is load balancing and other one is high availability, client side high availability. We'll discuss in our regular classes what is this load balancing, what is this high availability. So scan, the default or the best recommendation is go with the 3 IPs. So default or the best recommendations is 3 IPs, and you can go more than 3 IPs. You can go with even 4, 5, 6, 7, 8, doesn't matter. But the 3 is the best practice or the best recommendations. That's the default configuration. Even you can go with one single scan also, doesn't matter, it works. But best practice or the minimum requirement or the default requirement is 3. Go with the 3 for the scan, or more than 3 also fine, but don't go for 2 or 1. So you will not be able to get this HA. You can call it as a client side load balancing. We call it as a client side connection load balancing. We'll talk about that in our regular classes. If you go with a 1 or 2, you will not be able to achieve this client side load balancing. Go for minimum 3, then you will be able to achieve this client side high availability or client side load balancing, right? So in general, in overall, if you want to do a 2 node rack setup, you need a minimum 9 IP addresses, right? Any questions so far? Right, a couple of questions in the chat here. Mandatory scan IPs, yes, scan IPs are mandatory and must, you should have it. As I said, you can go with the 1 or 2, or the best recommendation is the default is 3. Go with the 3 is the default configuration, or even you can go with more than 3, 4, 5. And one more question, can I assume :1 is always node VIPs remaining 2 and 3? No, it's not like that. It may be varies. :1 can be scan and :2 and 3 can be your VIPs. That is just a VIP. It may be :1 or :2 or :3. It may go anywhere. That's what I said. Manually identifying whatever I just explained with a layman term here using this IF config and all, it's very hard. It's just assumptions, you can do it. You have to use these actual commands, then only you will identify. Same command you can use shl config VIP, which will give you node specific VIPs and all. You have to run this command to identify, not like using this IF config. That is just a layman term I just explained, right?
Okay, sir. Means for 2 node rack configuration, minimum 7 IPs needed, correct?
Minimum 7 IP
Minimum.
needed, yes.
Yeah. Okay.
Right. And now one more question, very interesting one. Usage of node VIP and private IPs. And there's one more question from Balaji: how user can connect to DB? That's again, your rack internals, how the connection workflow will go. Right. Now, let's say here, let's understand these questions. Usage of node VIP and the private IP. Node VIP and private IP, how we can do that usage? Let's say this private IP is for node to node communication. This private IP, as I said, it cannot be accessible outside. We will not be using this private IP. for any connections. This private IP is for only for node to node communication. What is node to node communication? Let's say client 1 connected to node 1. He did some select statement like employee table, and employee table where employee ID is 100. Employee ID 100 information. So we have this shared storage here. We have a shared storage data is here. And the moment this client 1 connected to node 1, and we have this instance 1 here and instance 2 is here. Again, by this time you might be aware what is instance. Instance is nothing but memory plus background process, right? If you are already aware of database architecture, you will be aware of what is instance. Instance is memory plus background process. In that memory, you have SGA and PGA. In that SGA, you have this database buffer cache, shared pool, large pool, Java pool, stream pool, and all those things, right? So he did a select star from employee table where employee ID is 100. That employee ID 100 is on the local disk. And he is going to read that employee ID 100, and that record will be kept under your buffer cache. The instance, whatever that rack 1 ORCL instance 1 buffer cache, we kept that employee ID 100. And we know that anything, this is a disk actually, this is a storage, right? This is a storage, ASM storage, which is stored under that disk. Anything data reading from the disk, it has to go to disk, do a IO, disk IO. It has to read and it has to take that record back IO. It has to write it back to buffer cache and give it back. So this select statement is it's going to be very costly because it has to go to disk, read the data and write it back to buffer cache and then give it back to that end user. The client 1, whatever he ran it, it will be like very costlier. Let's say client 2 connected to the node 1 and he's running the same thing. Select that employee ID 100. This client 2 will directly get the result from this buffer cache because data is already available in the buffer cache. It will never go to disk again because data is already available in the memory. Buffer cache likely get the result. This is called cache hit. First one is cache miss, means the data is not available in the buffer cache. That is cache miss. Again, these are like basic terminologies you might be aware in your database architecture. Cache miss is the data is not available in the buffer cache and go to the disk, get the data, write into buffer cache and give it back to that client. The client 1 is called cache miss. The data is not available in the cache. So I went to disk and fetch the data. And the second client who is connected on the node 1, it is called directly get the result from the buffer cache because the data is already available in the buffer cache. No need to go to disk. That is cache hit. And client 3 connects on node 2. And he is doing the same thing, select star from employee 100. What happens here? In this buffer cache here, whatever the buffer cache we have it here. In this buffer cache, we don't have that employee ID 100. What happens here? Will that go to disk and get the result and write it into buffer cache 100 here and then give it back to user? This not work like this. If this is the case, what's the use of RAC concept?
Cache fusion.
Anything reading from the IO is always costly. The disk read and writes are always costly. So in that case, we have something called cache fusion. What happens? It will not go to disk. Out of these two nodes, node 1 and node 2, either node 1 will be master. Any one will be in the cluster. We call it as a master node. Either node 1 or node 2. Any one will be master node. In this case, assume that I have 3 nodes. Let's say I have 3 nodes. Assume that I have 3 node rack. And in this case, node 3 is a master. Let's go with the 2 node also fine. Let's simplifying. I'm making it a 3 node. It's a 3 node cluster and node 3 is a master node. Assume that that's any one node in the cluster will be master. And right now node 3 is the master. Master node always having something called one important table, GRD. GRD table, global resource directory. We call it as a global resource directory that will be always available in the master node. This GRD table is nothing but this GRD table is a tabular column which will be just having node 1, node 1 having employee ID 100. Node 2 does not have anything. Node 3 does not have anything. Any data read by any client, any data available in that particular node buffer cache, all will be marked in this particular GRD table. Right. When this client 3 connected to node 2, he needs that buffer cache, the employee ID 100. This node 2 will directly go to master node. That is your node 3. It will go to node 3. Boss, I need this employee ID 100. Is any of the cluster nodes has that data? Your master node will say, yeah, node 1 has that. You're going to communicate back. Yes, node 1 has that data. Go to that node 1. Your master node will tell to that node 2 that, okay, node 1 has that employee ID 100. Go to that one. And node 2 will directly request the buffer cache 100. And then directly node 1 will give it back. So to get that 100, it made 3 calls. What are those 3 calls? From node 2, it made 1 call to node 3, master node, and master node responded back. That's the second call. And node 2 made again call to node 1. It's a 3-way GC. We have a 2-way, 3-way GC events. It's called 3-way GC events because to get that employee 100, it made 3 calls. One is go to master node, first call. Master node will tell back, okay, it is available on node 1, and node 2 will again make a call to node 1. That's a 3-way GC. And 2-way GC, we have it something like that. So we're going to make that calls. Because of that, it calls 3-way GC wait. And the moment it calls, okay, can you give me that employee ID 100 information? And this node 1 directly give that data from the buffer cache, directly from this node 1 buffer cache to node 2 buffer cache, the data will be transferred. The transferring the data from one buffer cache to other buffer cache is called cache fusion. And this is one of the common question in most of the interview. What is cache fusion? Cache fusion is nothing but transferring the data from one buffer cache to another buffer cache in a cluster nodes. That is called cache fusion. And which network this data will be transferred from one buffer cache to other buffer cache? The private network. Because the private network is between node to node communication. The data will be transferred from one buffer cache to other buffer cache. Directly from node 1 buffer cache, data will be transferred to this buffer cache and data will be given back to that user. This will be very, very faster because it is no need to do a disk IO. Directly get the data from the buffer cache and then give it back to that end user. Reading the data from the memory is always faster. That is one way. So we understood now different concept now here. One is buffer cache. Buffer cache is what? Transferring the data between one buffer cache to other buffer cache within the cluster nodes. That is cache fusion. And which network cache fusion is uses? Cache fusion uses your private network. That is second concept we understood. And what is private network? Private network for node to node communication. That's the internal to the cluster. And this private network will be used for this cache fusion, the block transfer between one buffer cache to other buffer cache. And the other function of your private network is to node communication. The node 1 will ping, okay, I am alive at this time. What about you? Node 2 will respond back, I am also alive in the cluster. So node to node communication, we call it as a network heartbeat. Network heartbeat. Network heartbeat between node to node communication. So node 1 will ping node 2, I am alive. What about you? Node 2 will respond back, okay, I am also alive at this time. And node 2 will ping node 1, I am alive. What about you? And node 1 also will respond back. That is called network heartbeat. So if node 1 pings node 2 and node 2 did not send any response, and node 2 will be removed from the cluster. And we have something called background process, CSST, cluster synchronization service daemon. which is responsible for node eviction. We call it as a node eviction. Again, one of the common question in the interview, what is node eviction? The node eviction may occurs because of this network heartbeat failure. Node 1 will ping node 2 and node 2 did not send a response. Then CSSD process of node 2 will evict that node 2. Node 2 will respond, node 2 will ping node 1 and node 1 will not send any response, and CSSD process of that node 1 will evict that node 1 from the cluster. Right? That is your network heartbeat. Again, private network will be used for this communication. Right. There's a one more heartbeat, that is the disk heartbeat. Disk heartbeat, again, we have something called voting disk. So if I cover voting disk, it will be too much for now. I'll just give one example. Voting disk will be available on your storage here, and node 1 will access voting disk and node 2 also will access voting disk. If the node 1 is not able to access voting disk, and node 1 will be evicted from the cluster. If node 2 is not able to access voting disk, and node 2 will be evicted from the cluster. Again, CSSD process will take a call to evict that cluster nodes. That is a disk heartbeat. Again, the disk heartbeat also from node to disk, node to storage. Again, it's going to use this private network for the disk heartbeat. So node, network heartbeat and disk heartbeat. Network heartbeat between node to node communication, and disk heartbeat is between node to your storage. That is basically your voting disk. Both heartbeats, network or disk heartbeat, uses again private network. Right, we'll talk about in detail about this network heartbeat, disk heartbeat, voting disk, and how that communication happens in further classes. Yeah, but that is just understanding now. That's the second concept what we understood. And other concept what we understood is master nodes. Any one of the node in the cluster will be master, and that master node will be having GRD table, global resource directory. So that global resource directory is nothing but a table which will be having a list of buffer caches. Each node buffer cache, what information that has. And in this case, node 1 has that buffer cache. To get that one, it has to make a 3 calls. First go to master node has to respond back, and again it has to go to node 1. That's a 3-way GC buffer. And assuming that master node is on node 1, this is your master node, and the same client connected to node 1 and requesting for employee ID 100. What happens here? Okay, this node 2 will get it. Okay, where is the master? Okay, node 1 is a master. We'll go to master node. Boss, I need this employee ID 100. Where is the employee ID? Any of the cluster node has that information. This master node will say, okay, myself, I have that 100 employee ID 100 information. Go ahead and take it. Right now, we made only 2 calls. From the node 2, it went to master node, and master itself has that record, and master will respond back, okay, myself, I have that record. Can you take it? And it make only 2 calls here. It is called 2-way GC buffer. So these are like your GC buffer events or weights, you can say. Furthermore, if you go for performance tuning class and all, so we'll see that 3-way GC buffer, 2-way GC buffer. This is only 2-way now because it went to master node and immediately it got a response. Okay, myself, I have that result. Only 2 calls, one going to master and master is responding back. 2 call and directly got that buffer cache. And other way, it's a 3-way. It went to master, that's a node 3, and master told it is available on node 1. And again, node 2 made a call to node 1. That's a 3-way GC. Right? You can see more often in AWR report when you run it, 3-way, 2-way, because RAC cluster, it's a common 3-way, 2-way GC buffers and all. Right. What else we discussed? Right, yeah, that's too much. I'm gonna take a pause now. If I talk continuously, it will be too much. I'll take a pause and then I will ask for any questions if anyone has it. So far, whatever we discuss, anyone has any questions? It may be networking or it may be architecture part, whatever we talked. It may be any public network, private network, VIPs. Any questions?
Malik, what details are required in the user side to connect to the database?
No, we lost the voice. Come again.
What details are required in the user side to connect to the database?
TNS details.
Only TNS. What about scan?
Again, TNS details is what? TNS details contains either scan or VIPs or node IPs. For client to connect to my database, they need a TNS details. What that TNS contains, it may be a scan, it may be VIP, or it may be a node IP. They just need a TNS. Yeah. How you configure that other different stories.
Sir, for 3 node,
Thank you.
there will be 9 IPs plus
Yes.
scan IP. How many scan IP? 3. Can we increase it to 4, 5, 6?
Whatever you can go for.
Okay. And how do we control? How do we generate that scan VIP?
That is again networking part. Your network admin will help.
Oh, okay. All right, sir.
So Malik sir, we have two hosts on the screen, right? For
Right.
example, say I want to configure rack setup in this. So I decided to install the ASM software and host node 1. So I installed using the grid setup. So how it is automatically installing on host node 2, then
That's
can-
where the installation part will come into picture, right? We are going to talk about installation part end to end in our, if you go here in our Linux configuration, network setup, and your cluster setup, and we have this system requirement, software kernel group directories, and your SSH equivalence. This is very important. So we do passwordless SSH connection from node 1 to node 2. You can connect without any password. And because of that connections, you can copy that, automatically software will copy it. Just to show demonstration here, I'm right now on node 1, and now I log into Oracle user. This is one of your prerequisites. Right now, if you see here, I'm into Oracle user, I'm at node 1. If I do SSH node 2, I don't need any password. I'm doing like right now I'm at node 1. If I do SSH node 2, connected to node 2 without any password. So this is one of the prerequisites you have to set up here. You can see here SSH user equivalence. Once you do this SSH equivalence setup here from node 1 to node 2, the moment you install the software on node 1, automatically it's going to copy it on the other node without any password. That's one of your prerequisites. You have to do it. We'll discuss more in our regular classes. All right. Any questions, guys, before we wind up or stop it for today?
Sir, suppose to identify the master node, you said that where on which node you will see the GRD table, that will be the master node. So how
Right.
we will check the GRD table?
It's not a GRD, it's an internal table. We're not going to do anything on that one. It will be maintained by that master node. The question should be how to identify the master node.
Yes,
We
yes,
have
correct.
various methods, various commands to identify the master node. You have o columnar command to run that master node, or you can go to your crsd.trace file. It's going to tell you which is the master node, and your crsctl command to identify which is the master node. For our job is to identify which is the master node, and we can see that master node will be having a GRD table, and that GRD table will be used for internal communication. As a DBA, we don't do anything on that GRD table. And suppose if this right now node 3 is a master node and which has the GRD table. Suppose your node 3 automatically went down due to some network issue or OS issue, automatically went down. What about this master node? Automatically any one of your cluster node will take that master. And for example, node 2 will take that master, and node 2 will become master, and that GRD table will be automatically shifted to your node 2. That's a internally cluster will handle that one. That's where that cluster software comes into picture. Right. So internal understanding in cluster, any one node will be a master. That master node will be having that GRD table. Right. Any questions?
Sir, uses of node VIPs.
We have so many things that will be too much if I talk now.
Okay.
We have node IPs, physical IPs, VIPs, and public IPs. And why node IP came? Why node VIP came? Why scan IP came? Why this private IP came? That is all will be your internal. So we're going to talk about that in our regular classes. In simple word, VIP is basically for your load balancing, or whenever, not exactly load balancing, whenever any client connected to node 1, the moment node 1 goes down, and okay, I'll just give one example here. Let's say exit. Now let's say if config or CRS CTL stat resource -t. You have node 1 VIP, and that node 1 VIP is available. Right now you can see node 1 VIP, and that node 1 VIP is available on node 1. And
Can't see your screen.
that's it. Okay, fine. Let's see now if I do on node 1, if I do CRSCTL stat resource -t, and I have this node 1 VIP running on node 1. If I do shut down my cluster here, CRSCTL stat resource, or else before that, if I do ifconfig, and my node 1 VIP is 190. And if I do 190 here, so 190 is my node 1 VIP, which is available on node 1. So again, I can see here node 1 VIP, which is available on node 1. And again, with the ifconfig also, I can see 190 is a node 1 VIP available on node 1. If I do CRSCTL stop CRS, if I do shut down my cluster on node 1 and go to node 2, the node 1 is getting down here. And if you see here, node 1, your scan 2 VIP, scan 3 VIP. You have two VIPs, scan 2 and 3. Scan 2 and scan 3 on node 1. And my node 1 VIP is also on node 1. 3 VIPs on node 1. If you see here, this is 1, 2, 3 VIPs are on node 1. Any clients are connected to node 1, they are connected to via VIPs, the scan VIPs through your node VIPs. And the moment if any downtime occurs on node 1 went down, cluster went down, and you can go back to node 2, and all those VIPs will be failover to your existing node. Plus ASM2 plus ASM2 CRSCTL stat resource -t, CRSCTL stat resource -t. Right here, if you see node scan 2 and scan 3, which were running on node 1, now they automatically shifted to node 2, isn't it? And now you can see node 1 VIP, which was running under node 1, now it is shifted to node 2, and it is saying failed over. So it means any clients who are connected to node 1, they all shifted to node 2. That's where we talked about in our yesterday's class here, right? Let's go back here. Any of the client who are connected to node 1, automatically node 1 goes down, or cluster goes down, or the host goes down. All these clients, how they will connect to node 2, or they may connect to node 3. How? Because of this load failover. So whatever you're seeing this failed over, it means all those connected clients are failed over to node 2. They may go to node 2 or node 3 or node 4 based upon your cluster nodes. So that is the use case of your VIPs. Client has to connect using VIPs. If they connected using VIPs, automatically they will fail over. Let's say I have this client 1 who connected to node 1 using this physical IP. And I have this client 2 who connected to node 1 using this VIP. Client 1 is connected using the node IP, client 2 is connected using VIP. And automatically this client 2, if assuming that this node went down, cluster went down, the client 2 who is connected via this VIP, automatically his session will fail over to node 2, and this client 1 session will be terminated. Right? I can say client 3 connected to scan, via scan he connected to node. Client can connect using various method. Client can connect to node 1 using node IP. Client can connect to node 1 using node VIP. Client can connect to node using a scan IP. And again scan also, if the client is connected to scan, his connection also will fail over to node 2. This is my client 2 and this is my client 3. What about client 1? Client 1 will not be able to fail over because he connected with the physical IP, and if the node goes down, that physical IP will go down. That's where VIP comes into picture. Why this VIP came into picture? Any clients want to connect, they have to connect via node VIP, or they have to connect via scan. And in simple words, in 9i, we have only this physical IP, this public IP. We don't have this node VIP in 9i. We don't have this scan IP in 9i. Let's quickly, I can take 1 or 2 minutes and explain here. Okay, as of 9i, let's say 9i. In 9i, we don't have this VIPs. We don't have this scan IPs. Client 1 used to connect to this node IP and connect here. And if the node goes down, and his session used to terminate. Because the moment node goes down, this physical IP will go down. There's no failover concept here in 9i. Right? What happened in 10G? In 10G, they came up with this VIP concept and no scan in 10G. They came up with this, the client, we requested them to connect to via this VIP. From the VIP, they used to connect. And if that node goes down, automatically that client used to connect to node 2 automatically. That's your failover because the VIP will fail over, right? In 10G, we are able to achieve this failover. But the drawback with this one is what? Right now, I'm having only 2 nodes. Client can connect in that client connection string. Let's take it here. That will be too much, but I can. Do I have that one? No. Give me a second. I wanted to show that scan details. Okay, here it is. Right. Let's take this. Go back. Client used to do like this. Right. Client used to have this TNS details, ORCL, node 1 and node 2. And they used to connect either node 1 or node 2 using this TNS details because they don't have this scan in 10G. And right now we are having only 2 nodes. And over a period of time, if we added 2 more nodes, and we need to communicate all the clients, if there's a thousands of clients, can you make your all the TNS details changes and include your 2 more nodes? Right? And over a period of time, if you increase another 2 more nodes, we need to ask customer, can you include this 2 more host details into your TNS files, node 5 and node 6? Because there's no scan. Client has to have this TNS details with our node VIPs. Because if they connected via VIP, then only that failover occurs. But if you expand your cluster, adding a node or deleting a node, you have to every time you have to reconfigure your application and you have to communicate with your all the clients. Can you do a modification on your TNS files, include these hosts? That's a tedious job. And whenever you expand the rack or whenever you delete the cluster nodes, you have to inform all the clients. If you have thousands of clients, all those thousands of clients, they have to change their TNS details. That's a tedious job. And because of this one, we came up with a scan. Instead of adding these VIPs, remove everything and directly put one scan name here. Whatever the scan, you can just put a scan name. This scan internally knows how many cluster nodes you have it, whether it's a 2-node cluster, 3-node cluster. Today I am having 2-node cluster. I have node 1 and I have node 2. And tomorrow I'll add 2 more nodes, and scan internally immediately know that, okay, it is a 4-node cluster. So I no need to inform my client. Client, I'll just give the scan name. Client will connect scan name. Later I can add a new node or delete a node from the cluster, doesn't matter. Client, no need to worry at all. Client side TNS details, I no need to change at all. I'll just give the scan details to client. Client will connect with the scan. Right? That's where the scan came in picture in 11G onwards. In 11G, the scan came into picture. The scan came, and then we are giving the scan entry to customer so that they no need to do any changes in their TNS details. Whether you can add a node or delete a node, it all will be dynamically handled. Right, I will talk more details on that. Why node IP? This is a simple understanding. In 9i, we have only node IPs. In 10G, we introduced with the VIPs, and in 11G, we introduced with the scan IPs. All right. Let's stop it here for today. Let's see you on our regular classes starting with the next weekend. Provided if no one has any questions, we are good to wrap it up for today.
Yeah, Malik, one last question, like what are the main differences between the rack with standalone and with rack with multi-tenant architecture? Not architecture, but the main differences, high level.
Nothing, no difference at all.
Okay.
Multi-tenant architecture itself is a different concept. Whether it's a rack or the standalone, it's all remains same.
So our
And
training includes that with multi-tenant only, right?
right.
Thanks.
All right. See you in our next weekend with the regular classes. Hope like whoever registered last yesterday and day before yesterday, I have not granted the access. Probably I'll grant access today and then I will share further communication in our WhatsApp group. Stay tuned on that. All right.
Gia,
Malik, still we can register, right?
Right. Yeah.
Okay, sure.
All right, guys. Let's wrap it up for today. Let's connect on next week. Thank you all.